Hello guys, here's a problem from Great Exam. It goes like this. For the function f of x equals to e to the power x mod of sine x belongs to the set of real numbers. Which of the following statements is or true? First option is the function is continuous for all x belongs to the set of all real numbers. Option number two is the function is differentiable at every real x. The option number three is the function is periodic. And the last option is the function is bounded. So let's solve this quickly. The first option is true because e to the power x and mod of sine x both are continuous, and we know that the product of two continuous functions is continuous. Therefore, f is continuous, so the first option is correct. Option number two, the function is differentiable at all x belongs to the set of real numbers. This one is slightly tricky because we have a mod here, and sine function changes its sign at 0. And therefore, we need to check separately if this function is differentiable at x equal to 0 or not. So let's do that. To do that, we need to investigate if this limit exists or not. And how do we do that? We first find out the left-hand limit, that is this limit as x tends to 0 from the left. So fx is e to the power x mod of sine x divided by x, because f of 0 is 0. And what is this? Well, this is equal to limit of x tends to 0, e to the power x sine x upon x, and we have a minus sign here because sine x is negative when we approach 0 from the left hand side. To make it positive, because of the mode, we need to multiply by minus sign. So this gives me minus 1, and the right hand limit is equal to plus 1, which is not equal to minus 1. Therefore, this limit does not exist. In other words, this derivative of f at 0 is not defined. So the function is not differentiable at x equal to 0. Therefore, option number 2 is false. Option number 3 is the function is periodic. Let's see. If the function were periodic, then there would exist a time period t, a positive number, such that f of x equals to f of x plus t for every real x. Let's see what happens if we assume this. So left hand side becomes e to the power x times mod of sine x, and the right hand side is e to the power x plus t sine of x plus t. And this is true for every x. So in particular, it is true for x equal to 0. If I put x equal to 0 here, what do I get? I get this. And e to the power t is positive. So this quantity is 0 only if sine of t mod is 0. But mod of sine t is 0 only if sine of t is 0, which is possible only if t is integral multiple of pi. And here n has to be non-zero because we can't have t 0. So what happens if I compute this quantity f of pi by 2? F of pi by 2 is essentially e to the power pi by 2. And what is f of n pi plus pi by 2? Since we assumed f to be periodic, we would expect these quantities to be the same. Let's see what we get. We actually get e to the power n pi plus e plus pi by 2. And we can see that these quantities are not equal. Therefore, f is not periodic. We have a contradiction here. We assumed f to be periodic, but f is not periodic. So that's the contradiction. Therefore, f is not periodic. So option number 3 is false as well. How about the option number 4? The function is bounded. Well, we can see from here that as we increase n, value of f also increases. In fact, there is no upper bound for f. Right? So we can increase f as much as we like. Therefore, f is not bounded from above. In particular, f is not bounded. So the option number 4 is false as well. So the only correct option out of these four options is option number one.